provided or sponsored or provided by emergency reporting. When we announced this last week, the plan was to cover the output clause and derived tables. But as Aaron started looking into his half of the presentation, we discovered that that's not quite the right title for the presentation. So it's been renamed to Output Clause and Correlated Sub-Queries and Sub-Query Extensions. It's the stuff that we talked about in the right chapters from last week, but just a little bit better naming on it. So presenting today, it will be me, Steve Stedman, and Aaron Buma, and we're part of the research and development team at Emergency Reporting. For those joining us remotely, for any questions via Google on-air broadcast, we'll address most of these at the end of the training. But if there's something appropriate along the way, feel free to ask it. And also, if you're using the Google on-air broadcast to watch it live, you can use the thumbs up or thumbs down to give us feedback along the way. Training, again, is provided by Emergency Reporting. That's part of our role here in the R&D team, is to share what we know about SQL Server with everyone else on the development team. And slides and sample code are available at my website right now. You can download those at stevestedman.com. It's the most recent blog post. And part of the live broadcast is that we're using Google On-Air Broadcast, and there's about a 30 to 50 second delay, sometimes around a minute, from live to what you see. So what that means is if when we're speaking, you're getting it about 40 to 50 seconds late. And oh, hold on, I just realized I forgot to share the right screen. Let me share. Here we go. So the live broadcast is a little bit of a delay, and but we're still learning how to properly use Google on-air broadcast, so please be patient. And that's kind of funny that that came up right as soon as I realized that I was showing the wrong screen on the broadcast. That's all right. So let me just double check to make sure I've got this right. Entire screen. Right. The sections will be available on my YouTube channel about an hour after the presentation ends. It takes a while for YouTube to process it. So if you missed anything or you want to go back and rewind and run through it again, just go to stevestedman.com/YouTube, and that'll redirect you to the YouTube channel where all the training will be available. And then as far as questions, we'll have lots of time for questions at the end of the session. And there's a Q&A app in Google On-Air Hangout panel. Up in the right corner, there's a 3x3 grid icon that you can click. And when you click that, you get to choose Q&A, and that will pop out a panel where you can ask questions and view other people's questions. Just keep in mind that when you ask a question, it's about 40 to 50 seconds delayed. So this week, we're going to be covering correlated subqueries and subquery extensions. Aaron's going to present this section, which will cover correlated subqueries, extensions, the any, all, and some, and then we'll also be taking a look at the exist clause. Additionally, or after that, I'll jump into the output clause, and I always get a little bit excited about this one because it's one of those that's often overlooked, and it's really, really cool the things you can do with it. So at this point, I will hand it over to Aaron.
All right. So I'll be covering correlated subqueries and subquery extensions. A correlated subquery is how you can join a subquery to the outer query based on a specific column. You can use that to filter the subquery. You can use a correlated subquery in the select columns, in a join, or as a filter in the where clause. Subqueries can return and can return result data to the calling query on the outer side, and you can nest up to 32 queries together. All right. Subquery extensions, you use them in the where clause of the outer query to kind of change how the result sets or how the conditions are handled in the correlated subquery. I'll go through each of them, all, any, some, and exist, and then we'll go over some demo. At the top here, you can see the syntax for the all correlated query operator. And in this case, when you use the all, it will only return true from the correlated subquery if all results match the condition. In this case, all of the values in column 1 are greater than or equal to 5. if one of the values or one of the rows in the result set for that correlated subquery is less than 5, it will resolve false for that entire condition. The any operator will return true if any of the values in the correlated subquery match the condition, in this case greater than or equal to 5. The sum operator is exactly the same as the any operator. It is just the ISO standard. So you can use any and sum interchangeably. The exist operator has a little bit of a different syntax. You can see on the top there, you say where exists, and then you have your correlated subquery. In the correlated subquery, you can have a hard-coded value as the column. You can return a column. It doesn't really matter because there are no results returned out of that subquery when you use exists. That condition only returns a true or false, and it returns a true or false when the first match is found. That also means that it is faster than the any or sum operators, because the any or sum operators process the entire result set of the subquery before saying the condition is true or the condition is false, whereas the exist stops processing at the first true row that's met. All right, we'll get into demos. First, we'll demo basic subqueries and correlated subqueries, and then we will demo the operators. All right, so first off, we will drop and create the database. We will create a inventory table. It's around our camping store that we use for our samples. It contains category and item and inventory information around that item. We'll create a categories table, which will be referenced in the inventory table, and we'll fill them with some sample data. So first, we'll run some queries without using a correlated subquery. We can see here that in the inventory table, if we know the category IDs, we can filter on those and get those 4 rows there, 3 of which are in category 1 and 1 of which is in category 2. And then we can I'll run this. So there's this query, say we know the actual category titles, same category IDs, 1 and 2. And we put that in an in statement and it's a subquery pulling from the inventory table. We can see the same results here. So those are just some basic subqueries. Those are not correlated subqueries. So we're going to do correlated subqueries now. The first query just is a select star from the inventory table. We can see the category IDs here, and then a select star from the categories table, and there's the category IDs there. And first we will run this query, and what it does is gets a count of inventory items per category ID. You can see it's grouping on category ID. So what we're going to want to reference in our correlated queries, we're going to want to reference on category ID and return the items in the category or the count. So if we took that query that we just ran, we put it in the select portion of a query of a select star from categories, and we filtered the subquery on category ID. You can see here I aliased the inventory table as I2 and aliased the outer query as C. So in this portion here, we filtered the subquery on category ID, and this causes it to be a correlated query. We can see the select star portion was the first 4 columns listing the category IDs, category title, description, and the archive column. And then the last column is a count from the inventory table for each item in that category. How can we list the items along with a count of how many items are in the same category? Here's the correlated subquery. A count of inventory items from inventory grouped by category ID, where the subquery is filtered on category ID to the outer query on category ID. We'll run that. We can see here that we get all of the records from the inventory table. And in the last column, the value returned from the correlated subquery, we get a count. There's 3 items that are in category of 1, 1 item in category of 2, 1 item in category 3, and these items are in category 4, and there's 2 of them, so we see 2 in that column. So you might ask, well, how can I get that same result set, but I want to have a count of how many other items are in the category? So we want to exclude the current item that I'm looking at in the outer query. You can have multiple correlation columns in your correlated subquery. So here, this is the same query as the one previously, same subquery, but I added where the subquery inventory ID does not match up with the outer inventory ID. You can see that we know there's 3 items in category 1. For each item in category 1, there's 2 other items in that category. For categories 2 and 3, there are no other items, so it's null. In category 4, there's 1 other item. Nulls don't look very nice, so how can we account for nulls? You can put an isNull statement around a subquery in the select clause or in the filter clause and have it return a 0, so you can have a better, cleaner result set. On to subquery extensions. Any, all, and some, and exists. So return a list of categories that have a quantity on hand greater than or equal to 5. This little query here is just going to show us the inventory table and all its information, and then I join to the category table so we can have the category titles and see what we're looking at. This first query we'll look at is the all, using the all operator. And you can see in the result sets that it did not return any records from the sleeping bag category or the food category. That is because we're filtering on quantities in this correlated subquery that are greater than or equal to 5 with the all operator. In the sleeping bag category, there's 1 record with a quantity of 1. In the food category, there's 1 record with the quantity on hand of 1. Therefore, with the all, since not all of the records match for that category, this resolves as false, and it's not returned in that result set. Category 2 has 0 records less than 5, and category 3 has 0 records less than 5. Now we'll look at the any operator. And we can see that, I'll just hide that. Any means that if there's any rows in the correlated subquery that match the condition, then return it as true. So previously sleeping bag was excluded because it had a quantity of 1 with the all operator, but now with the any operator, it has 2 rows that match the condition. So we see the sleeping bag category and the result set. Tent and axe are also included, and food is now included as well. And we'll run the sum operator, which is the exact same as the any operator, just ISO equivalent.
Why would there be 2 different ones that there's an ISO standard and then somebody else made a different language or a different function of the same thing?
So the question was, why is there 2 operators that do the same thing, the same operator and the any operator? And I think the any operator was created to run SQL in the ISO standard sum. We can translate between the different databases.
And it also, it may have occurred that, and I don't know the exact timing on it, that at some point in time prior to the ISO, I think the ISO 99 standard, which was established in 1999, that they may have had the any already in the SQL Server at that point. I don't know, or at least planned in there.
Yeah.
And they had to probably add in some later to accommodate the standard.
And now
These all exist in SQL Server. Back to
Well, at least back to 2000. Okay. I don't know where they were added before that, but.
and then the last operator is the exist statement, and we can see the syntax is different. It's just where exists, and then you have your correlated subquery. If you have your condition inside of the subquery, so in here we say select from inventory and correlate on the category ID from the inner subquery table to the outer subquery table where the quantity on hand is greater than or equal to 5. I wrote this is not returned because this can be this hard-coded string here. It could be, the archived column. It doesn't matter. When we run it, we get all results because, as we saw earlier, each of these categories have an item where the quantity on hand is greater than or equal to 5. And just as a recap, the exist is the equivalent and returns the same results as sum and any, but it is also faster because it stops processing at the first instance.
Would it return if archive was null in that previous example? In other words, there is a quantity on hand of 5, but the column was null. Would that count?
So the question was, does it count if this column is null or if a null value is encountered? And yes, it does, because it's really only looking at this portion right here. No data is returned from the select statement. All right, that's it for my slides. In review, correlated queries, they're filtering a derived table or subquery based on a column from the main query. They can be in the select, in a join, or in the filters area, the where clause. All operator returns true if all rows fit the condition. Any and some return true if any of the rows match the condition. And exists will return true if any of the rows match the condition, and it stops processing at the first instance that matches the condition. All right.
So always use this.
So the statement was should you always use exist? And I'd say 99% of the time, yes. Depends, of course. Maybe your database platform doesn't have exist, but in SQL Server, I would say use exists. Steve.
right, thanks, Aaron. So the thing I like about this every week is even helping with the training is I learned something, and the any, all, and some was one that I didn't know prior to this week's training or prior to preparing for this week's training. So as we make the switch back to me presenting, the one thing I want to point out as we go through here, this training is sponsored by Emergency Reporting, and Emergency Reporting is paying for us to do all of this and to make it available to the not just the development team here, but to the entire SQL community worldwide. So visit emergencyreporting.com if you want more details. Right, on to the output clause. I don't know, I get too excited about some of these. The output clause is one of those things that it's just really darn cool. And what is it? It's basically a way to get a result set from queries that don't normally return a result set. So obviously with select statement, you're expecting a result set or something to come back. Well, with an insert statement, usually you don't get anything back. You do insert and you get a little statement that says X number of rows updated, or delete, it tells you how many rows were updated. And if you, at least if you have no count on. But the output clause makes it so insert, delete, update, and merge can return a row set, can return details on what actually happened in that statement. So for instance, with the insert statement, you can have it so it'll spit out as a result set a copy of all of the rows that were inserted, not just the data you inserted, but the entire row that includes all the identity values or default values, things like that. Delete can spit out the rows of what was deleted as a result set. Update will give you, update's a little bit different because with update, you can actually look at the before and after of what those rows looked like before they were updated and after they were updated. And then merge, very similar to the combination of these, but we're not going to cover merge in today's presentation. Next week, we'll be covering merge in full detail, and we'll take a look at the output clause when we cover that. So the availability of the output clause, it was introduced in SQL Server 2005, and it's been available on all editions since then, even SQL Azure. And so let's jump into the insert statement to take a look at. The way it works is you add into your insert statement a line that says output inserted.star. And inserted is a special table alias or row alias that refers to those values that were inserted. And that will display the entire row that was just inserted. Now, keep in mind, prior to this, one of the ways that we looked at before was how do you get the identity of an inserted row without the output clause? Well, you can use the @@ identity variable, you can use the scope identity or ident current functions. But with these, the question that always comes up is how do you get the return value multi-row insert? So with those three older ways of doing it, or different ways of doing it, you're only able to really get the last identity value. However, with the inserted on the output clause, if you inserted 20 rows, you could get all of the identity values back, as well as all the value in the row. So that's one of the benefits of using the output clause versus those other ways of doing it. So let's take a look at how to do that with the insert statement. Switching back to SQL Server Management Studio here. Same example database. I'm just going to drop query training and recreate it. I'm going to create a table called inventory. Same inventory we've been taking a look at in the previous trainings. And in there, I'm going to put some camping related stuff. And then I'm going to create a table called departments. And in there, I'm going to put some department things related to camping, cycle, fitness, and whatnot there. So we'll run the query, drop the database, get those tables recreated, and then let's look at what we've got in departments. So looking at departments table, it's pretty simple. In here, we have IDs of 1 through 8, and the first 4 are top level where they don't have a parent, and the last 4 here that have 1s defined mean that camping is the parent department of those. Just knowing the data before we proceed. And then let's take a look at inventory. Very similar here to what we've been looking at as well, where we have categories. We have an inventory ID, of course, the SKU, the description, quantity on hand, and some pricing related stuff. We don't have to worry about the archived column. We're not going to use that in the demo today. So let's take a look here at using the insert statement if we didn't have the output clause. So here, if we wanted to insert into the inventory table, keep in mind this sample code is also available on my blog, and there's links to the blog here where you can get more information. But if you wanted to insert a row into the table, you'd do something like this if you didn't know anything about the output clause. Inserting into the table called DBO inventory, you're inserting column names, and then here's the stuff that's going in. And in this case, somehow MREs were in there, so I just called it MRE ice cream, and it's chocolate. I don't know if chocolate ice cream comes in MREs, but it sounds a lot better than most MREs that I've heard of. So if we run that query, all we get back on our results is this 1 rows affected. And if we inserted 10, we get 10 rows affected. So all it does is it tells you how many rows you get back. So let's take a look at inventory, and we can now see that our chocolate ice cream was inserted down here at the bottom of the list. All right, now we can use those other methods for getting back the IDs that were inserted, but let's take a look at how to do that with the output clause. So here, exact same statement. The only difference is I've added this output inserted dot star right here in the middle of the query. So we're going to run that, and what we get back is not the number of rows updated. And even if we look at the if we look at the messages window, you can still see the number of rows affected, but we get back a result set. And in that result set, we have the ID that was inserted and then an exact copy of the entire row. So the inventory ID, which was filled in from an identity value, we can get that back. And then none of these happen to be filled in with default values, but if we had rows that had default values associated with them, you could get that data back. So if you were perhaps in your code trying to fill out an object or fill out a model in some way where you wanted to do an insert but get the entire row back, without knowing this, you would have had to do the insert statement and then say select. But with a simple output inserted dot star, you get the entire thing back. So we'll take a quick look at inventory just to confirm that it's in there, and you can see that the ice cream Rocky Road was inserted as the last item there. I don't know why I was thinking ice cream when I made this, but somehow I got off on a ice cream tangent here for a little bit. So next, let's take a look at what if we just want to get back the identity value that was inserted. So previously we used inserted dot star, but here we can use inserted dot and use any of the column names that were returned or that exist in that table. So when we run this one, we're going to insert vanilla ice cream, and you can see we simply get back just an inventory ID rather than the entire row. Now what about multiple inserts? Now this is the one that I don't know another way to get back the identity values that were inserted. This is the only way I know to do it. There may be one, but I don't know of one. So it's the exact same statement, other than at the bottom here, we've got 2 different food items that are being added. One that's ice cream for cookies and cream, and one that's ice cream for chocolate chip. Hopefully those in the room or those watching aren't getting hungry and wanting to go get ice cream right now. So when we run this, we're going to output the inventory ID, and we get a result set that has multiple rows in it. So if you were working on some code that you needed to then process over those and maybe add some items that were foreign key relationship to this table or something, you could then take that inventory ID or that list of inventory IDs and use it somewhere else in the code. Next, on to the update statement. So update, this is the one that's a little bit different because we already looked at the inserted dot star or inserted with column names. The update gives you 2 views of every row that you inserted. You can see the before and the after. The deleted contains the before view, or what was actually removed, and the inserted contains the after. Now, that might give you the illusion that when you run an update statement, it's actually deleting the row and reinserting it. That's not the case. It's simply the syntax here is the deleted means before and inserted means the after. So let's take a look at how we would work with that. So same thing, inventory. If we wanted to go in and update a row, I'm going to change this one, which, well, let's take a look at the list here. If we look at 213-ice here, that's this one, chocolate chip. Well, everyone knows double chocolate chip is better than chocolate chip. So we're going to update that inventory item to be double chocolate chip. This is plain old update statement, no output in it at all. We run that, you simply get the 1 rows affected like we saw before. If we look at what's in the table, you can see that that bottom one has been updated to double chocolate chip rather than just plain old chocolate chip. Now, what we're going to do is a similar statement. We're going to update the same item. Double chocolate chip is now going to be improved to be triple chocolate chip because in the store, the competitors came out with a double chocolate chip and we had to compete more. So, but what we're going to do is we're going to output deleted and inserted dot star. So it's going to show you the entire row before the update occurred, followed by, on the same row, the entire row after the update occurred. So when we do this, you can see here the first row, which is all of the data out to the archive column. So everything to the left of the archive column here is what the row looked like before that statement was run. MRE ice cream, double chocolate chip. When we look at the other half of it here, it's what it looked like afterwards, and you get the triple chocolate chip there. And however, everything else is the same. Now, it could be that you've got a trigger or something somewhere along the way that will change another column if a column changes. If that happened, if there was a trigger applied there, what would happen is that this would be displayed before all of the triggers were run. But now let's take a look at, just at the table again to confirm. Yep, down at the bottom, it's triple chocolate chip and not double chocolate chip. Next, what we're going to do is we're just going to rename that one to strawberry because we ran out of triple chocolate chip and now we're going to replace it with strawberry ice cream. And instead of displaying the entire row, I just want to show what changed. And in this case, we're only updating description, so we can output deleted.description and inserted.description to see the before and after. And if this works correctly, we'll see triple chocolate chip has now been renamed to strawberry. But looking at the column headers here, description is showing up on both of them, and you don't really know looking at the output necessarily which one's the before and which one's the after. So what we can do is we can alias the output just as you would alias anything in a select statement, and just use the as statement, and we're going to call one of the columns before, and we're going to call the other column after. And in this case, we're renaming what was strawberry, and we're renaming it to blueberry. And you can now see that the before value was strawberry and the after value was blueberry. What happens if we run that a second time? We get blueberry and blueberry because it was already blueberry from the previous time we ran it. We do the update statement and it now converts it to blueberry, so we got blueberry and blueberry. Shows that nothing was actually changed. And then if we take a look at the inventory table again, just to confirm what's there, down at the bottom, blueberry is showing up as our ice cream flavor. All right, now how about multiple rows? What if we're at this ice cream store and we're having some financial difficulties, or this camping store and we're having financial difficulties and we want to increase our prices? Now, oftentimes that drives customers away, but we're desperate and we want to increase our prices. So we're just going to update everything by 10%. So I'm going to update inventory. I'm going to set the unit retail, which is the retail price, the price tag that's on it, and we're going to multiply it by 1.1 or add 10% to it. And then what I'm going to output is the inventory ID, and I said deleted.inventory ID here. Technically, we're not changing that, so it could be inserted or deleted would return the exact same value. But we're going to say, give me the price before and give me the price after, so I can see how this changed. And when we run this statement, we get an entire result set showing all of the inventory IDs, the price before, meaning what it was before the update statement ran, and then the price afterwards. So you can go through and take a look, and maybe you would, if your accountant or finance person needed some detail on what the price changes were, you could use this as a quick update to show this is what we updated and this is what actually changed. It's also a great way, if you're doing more complex math in here or more complex calculations, if you don't know if it's exactly doing what you want it to be doing, you do it on a dev database, run this, and then compare the before and after to make sure that it's giving you what you think you're getting. Let's say we want to go one step further and take that output and do something with it. Instead of just displaying it on screen or getting it in a result set that you could access from your code, I want to throw it into a table. In this case, it's going into a temporary table called inventory temp table, but it could go into a table variable or it could go into an actual table as well. but it's just going to be a temp table. If you haven't seen temp tables, the pound sign at the front there implies that it's a temp table. 3 columns in here, just inventory ID, price before and price after. The update statement here, as it's highlighted, is exactly the same as we saw a moment ago. However, we add the into at the end of it that says, take that output that's coming back in that result set and push it into this other table. And then we're going to select everything out of the table, and then we'll drop the table just to be clean, just clean with what we're doing there. It's always good to drop your temp tables, otherwise they get left around. So we're going to run this. Again, we've already updated it 10%, so we're adding another 10% to it because we're getting really greedy with our customers at this point. And you can see here, we get the same result set, but what's different is we see 12 rows affected, and that 12 rows affected came from the insert into, and then the second 12 rows affected came from the select star from that temporary table. So at that point, we could have used that temporary table to do further processing or do something else with it along the way. All right, now on to the delete statement. So delete, we've already looked at the deleted alias here because that's what's being used in the update statement. But all it does is return the rows that were deleted. So you can say delete something. Let's say you wanted to delete all of the ice creams that were a certain flavor out of the store, but what you wanted to get back was a list of all the IDs. You didn't necessarily know those IDs. You could say just output where it equals a certain flavor, or delete where it equals a certain flavor, output those IDs. So we'll take a look at an example of that. Take a look at inventory here. We've got a total of 12 rows in there now. We've got all our ice creams down at the bottom. 213-ice, which is the blueberry one. We're going to delete that one. And when you run this without the output clause, you would simply get a statement that says 1 row is affected, or 1 row affected. In this case, it's going to delete it, but display what the row looked like before it was actually deleted. So we can run that, and we see we get the entire row back showing this is the ID, this is all the information associated with that row, but it's gone. So if we run this statement again, we get nothing back because we're saying delete a row that doesn't exist, therefore we can't display what it looked like before it was deleted because it was deleted previously. So let's just check our inventory table again. Now we can see we've got 11 items in there. We've got several MREs down here. And what if we wanted to delete where the output is like MR, which is going to give us all of the MREs, but it's not going to delete any of the sleeping bags, tent, axes, or other things. And then it's going to output the entire row of what's been deleted. So when we run that, here's the output. It's like saying select star where the values equal that, but these are gone. These are the rows that were actually deleted on that run. So what?
It's the SKU.
Oh,
Not the description.
Oh,
gotcha.
good point. Sorry, I said that wrong. So the where clause is on the SKU, not on the description. So pizza, even though it doesn't have MRE in the description, it got deleted because that's in the SKU here. Thanks for catching that, guys. I said it a little bit wrong to begin with. So now if we look at what's left in the table, it's everything that's not food related at that point. Yep.
We have a question here.
Oh, question has come up. Let me repeat the question. Are inserted .star and deleted .star columns the only options for the output clause? For example, if I have a complex update statement with several joins, is it possible to save related columns from tables being joined on but not updated? Okay, so looking at that, I don't have an example of that in the code or in the demo I put together here, but if you have a complex update or delete or insert statement for that matter, where you're using multiple joins as part of calculating what's going to be updated or deleted, what's being displayed here is the row from a table that is specifically affected. Because when you're doing an update or a delete or an insert, that, even with those complicated joins, that's eventually only affecting one row or multiple rows in a single table. So the answer is you're only going to get the deleted or the inserted rows from the table it's being inserted to. You can't say insert into two tables that way. So you can say insert, you get all of the columns from a table, but you can't get all of the columns from multiple tables. Hopefully that answers that question. All right, so now what I'm going to take a look at here is creating a new table called deleted inventory. And what I want to do is, and I know in databases I've worked on, and in fact this one right here, there's this archived bit. But what if instead of using an archived bit, you actually wanted to delete things out of a table and move them into a different table when somebody disabled it in the user interface? But you wanted to keep them around in that other table, like you normally would keep them around with an archive bit, but you'd make your table smaller because you're being split out into two tables. Well, the way you could do that, and this table here, deleted inventory, is almost exactly the same as the inventory table we've been looking at. The only difference is that the inventory ID I've put here is just an integer. It's not an integer identity or a primary key that's going to be filled in automatically for us. So what I'm going to do is I'm going to create that table. I'm going to look at inventory, which is not the deleted inventory, but the original inventory table, and we can see that we've got 5 rows there. I'm going to, just to show there's nothing up my sleeve, I'm going to look at the deleted inventory table, and it's empty, as you would expect, because we just created it. Then what I'm going to do here is I'm going to delete from the inventory table, and in this case I'm going to delete everything because I haven't specified a where clause. You could do a similar thing with the where clause to only delete part of it, but I'm going to delete everything. I'm going to output deleted dot star, which is the entire row, and I'm going to output it into the deleted inventory table. And when we run this, it's really the same as saying select everything, move everything from one table into another table. We run that, 5 rows affected. There's no output that we see on screen because of that, or because of the into statement here. We look at what's in our original table of inventory, nothing there. And we look at what's in the new table of deleted inventory, and it all exists there. Now, as I was looking at this, I thought, well, okay, that'd be really handy when you're doing like archiving or moving data around or just trying to purge something out of a table. The other thing that came to mind, this is more of a DBA rather than a programmer thing, but occasionally if you get table corruption in your database, and some of the solutions that you get for corrupt tables is to create a new table, select everything out of that table that's fine into the new table, delete the original table, and then put it back. But one way that you could do that would sort of different way of doing it would be to use this, where you say delete from one table where there's some parameters, move it over to the other table, and then you could drop the original table, recreate it, and then put your data back with this as well. So on to the next bit here, which is auditing. Now, the one thing that comes to mind oftentimes when we look at how to get this output of the before and after is, what if we want to log it and track that and keep track of what's been done for an audit trail? Now, prior to knowing about the output clause, I've done this on several occasions where you look at a row, you bring that all back into your code, you then insert it into an audit table or somehow into a before and after table, and then you go delete or change a table or change a row in that table. And it's a whole lot of, I mean, it's not that much work really, but it's more work than you really need to be doing because you end up with 2 or 3 or sometimes 4 queries to do what you could do with one simple query here. So let's take a look at how to use that for auditing. So back to our same database we've been working with, but I created the departments table earlier, and that just has these department names in here. Top level one, sort of in a hierarchy of camping, cycle, and snow sports, and fitness. And then under the camping category with the parent ID of 1 here, you have tents, backpacks, sleeping bags, and cooking. So what I'm going to do is create a table called Department Audit. And imagine if you had more columns in here that showed the status of everything in that table. But instead, I'm just going to have an ID that is the ID updated. I'm going to have the old department name and a new department name, which are both varchars in that case. I'm going to show what the parent is, and I'm going to show when the modification happened. And this is a real table, not a temp table. It's just a table I'm going to keep around. But instead of old department and new department, you could have old parent, new parent, old on any number, old and new on any number of columns that you're working with. And then, so we've got that table. Now what I'm going to do is I'm going to update the from departments down here. And departments table is alias is department here and used here. I'm going to, let's see, zoom in on this one here for a second. I'm going to update that table. I'm going to set the department equal to camp kitchen, where the department ID equals 8. So that's department ID of 8 happens to be cooking, I think, right now, and I thought that camp kitchen was a little bit more appropriate for cooking when you're out camping. And then what I'm going to do, I'm going to output here the deleted ID, which we're not changing, so it's going to be 8 in that case. The deleted department, which is a department name, which was cooking, I believe. The inserted department, which will be camp kitchen, and then the parent, and then I'm going to use get date to get the current date of the SQL server to show when this actually occurred. We highlight that and run it. Because we're using the into department audit, we don't get any output that's displayed other than the number of rows affected. And now I'm going to take a look at departments and department audit. And when we look at these tables, you can see that item 8, which was previously called cooking, is now been renamed to camp kitchen. And there's a log down here that shows today at 9:45, cooking was renamed to camp kitchen, and it happens to have a parent of 1. So if you have code in your database, or if you need to keep track of who changed what when, which is really good when you're dealing with something that maybe a customer could accidentally delete, or to be able to know who did what or when for any kind of auditing purposes, the output clause inserting into another table is a great way to do that. It's much cleaner, I think, than pulling all the data back, processing the data, and somehow pushing it into another table. All right, switching back then, that's the end of the demo. So on to a few gotchas here. When we're using the output clause, one thing that can happen is that you can get results even if the transaction fails. Meaning, you write a query inside of a transaction, something happens along the way with a deadlock or a foreign key constraint violation or something that causes that transaction to fail and roll back, but you've got part of the result set, either the before or the after, already in that output buffer. You may still get those values back in the output buffer. So you need to be able to check to confirm that you didn't get any errors or no exceptions, any of those kind of things when your queries are being run. Just because you got the results back doesn't necessarily mean that it actually occurred. And then the next gotcha to keep in mind is columns returned from the output reflect the data as it exists in those statements after that has occurred, but before the triggers are executed. So when we're looking at the inserted dot whatever, that's the value that's in the table prior to triggers being run. So what SQL Server is doing is it's actually updating the table, it's sending the data to the output clause, and then it's telling any triggers to be run. For people who don't necessarily know what triggers are functions that are associated with events on a table, meaning you do a trigger when something changes or when you delete or insert, it calls code that will manipulate or can use what's in that table. So keep in mind that if you have a trigger that says when you insert a name, for instance, that it calculates, like insert a first name that's going to go calculate your full name or something like that, well, the data you're getting here is before the trigger is actually run. Also keep in mind that the output clause is not supported in the following cases. One is data manipulation statements that reference local partition views, distributed partition views, or remote tables. So Not real common, most of those, but if you are using those, you'll want to be aware that the update statement doesn't work in that case. Also, insert statements that contain an execute statement. So for instance, you're inserting into a table something that's coming from executing a stored procedure, and that stored procedure generates output. You can't use the output statement with an execute in that case. And also that can be done to run code at a remote server as well, and it won't work in that case. Yep.
So is this a good example where you might want to use a temp table on the execute and then run the insert so that you can get the output you want?
Yes. So the question was, is this a good example to use a temp table to get the output you wanted? So generally, you can use execute to run a stored proc and get back a result set and insert it into a temp table. Yes, absolutely. That would work in that case. Yeah. Yeah. And then the next one is a user-defined function cannot be created if it contains an output into clause. So based off of that, yes, you can use the output inside of a user-defined function, but you can't use the output to insert into another table. So a quick review, the output clause works with the insert, delete, and update statements. It also works with merge, but we're going to cover merge next week. Oh, another question coming in. So
Based on the previous thing. So what he meant in the previous question around outputting columns for an update statement, outputting columns that are not part of the table that you're doing the update.
Oh, I see. Yes, let's see if we can create something like that. So the question was around outputting stuff that's not part of the update. So let's take a minute here and drop the database and recreate it. And then let's take a look down here. I'm going to we're going to try this. I'll create a transaction. So that we can roll it back without actually affecting the data. Yeah, so I'm going to start with just select from departments. Look what's in there, and we can see it's the same department list we had before. I'm going to, delete from department where department ID equals 8. Let's just confirm that that works to start with. We get one row affected. Yes, it was deleted. Output deleted. So we're just building here to build the foundation for it. Output. Oh, wrong spot. There we go. So we output what we deleted there. But what if we wanted to, from departments, what is that? Inner join.
So again, I guess join the inventory table. And
Well, I'm going to do inner join departments department 2 on department dot parent equals department 2 dot ID. So that'll join up the department and the parent. And when we run that, oh, whoops, oh, and it's gone because I accidentally messed it up without having the begin transaction. So let me just recreate it here real quick. All right, I think that will work. Begin in transaction, delete, and rollback. Oh, I think that's the actual problem. So let me just running department ID equals the join's not working. Join departments, department 2. Oh, whoops. There we go. So now we've got the results where we're seeing that it's pulling in sleeping bags as with a parent category of camping. Then we're going to delete from the original table, which would be the sleeping bag one, and then we're going to roll it back. So when we run that, you can see the results we get back are only from the original table that's being deleted. Delete department, output deleted dot star, and then there's possibly, could we say department 2 dot star? See what happens if we do that. I have a feeling that doesn't work. Oh, it does work. So yes, so we can include, when we're joining other tables, we can include them in the output clause. And in fact, you can include other things, other functions and things like get date in the output clause. So yes, you can include other things there, but just referencing the table name deleted only gives you what was deleted from your actual table. So you can add them in, but the deleted only gives you those.
Trigger. Like in a trigger, you can reference the deleted over.
And the deleted and inserted syntax, as Aaron's pointing out, comes from how triggers. And when you're working with triggers, the before and after state is referenced with those same names.
It's almost like they just exposed the trigger tables at an outer level or something, right?
Yeah.
Because if the triggers fire after, then it's the same inserted and deleted the trigger would see.
Yes.
Seems like.
Yes, that's a good point. It's the exact same things that the trigger would see before it has a chance to do anything with it. Yep.
Interesting.
Okay, so on to the quiz. Don't have a lot of quiz questions this week, but the first one, Aaron, do you want to?
All right.
Read this
so all of the following are true. So which is better to use? Any, some, or exists?
C.
Any because it comes first alphabetically, some because it is the ISO standard of any, or exists because it's more performant than any or some. 3.
All right, you got it right.
Yeah, C. That's correct.
Yep. So you might say, well, in that case, why is there such a thing as any or some when you really want to use exist? But the case is there may be certain cases where the business logic you're doing or what you're trying to achieve in that query, any or some may be a more efficient way of doing that specific job at that point. Okay, quiz 2, and this is the keyword here is better. Which is better to track or log changes to a table, the output clause or a trigger? The output clause because it has less overhead, therefore it's better, or a trigger is the best option since it guarantees the information will be logged? A. Correct answer is C. It depends on the specific environment and your specific needs. Now, the thing you want to keep in mind here is that in some cases, the output clause is better, and in other cases, a trigger is the best option. Now, keeping in mind that the advantage of a trigger is if you put a trigger on a table, it checks to see if anything's changed, and if it has changed, you're going to insert that into some kind of a logging table or an auditing table. That's guaranteed to be hit. Triggers are run every time, no matter what the person running the query against it has in mind. But when you're using the output clause, although yes, it is more efficient to do, if someone is writing a query or running an ad hoc query to change something and they don't have and they don't include the output clause, people are then able to change a table without anything ending up in the logging at that point. So pros and cons to both of them. So we're at about about an hour into it at this point. And I know we had an hour and a half allocated, but we came up a little bit light on our schedule today. So At this point, I just want to bring up any questions on the output clause or anything around the derived tables, correlated subqueries, extensions. Any questions on any of it?
Are you able to wrap the output clause into a function? Somehow.
Are you able to wrap the output clause into a function? I don't
So
really
I guess,
follow what you're asking.
the one thing I'm worried about is if you're gonna have all these output clauses like logging, we're gonna be duplicating where you're logging to potentially.
Oh, to say output and then call a function there.
Yeah, something where you could remove duplication.
No, I don't think that works. And the reason is that the actual output line itself refers to the inserted and the deleted values. And those wouldn't be available necessarily inside of a function. You might, I don't know if you could pass them to a function, but the into statement has to go into a table or a temp table or a table variable. So we can play with that, but I don't think there's a way to do what you're asking there.
You can call a function and trigger them.
Yeah, so that's one where there's a little bit of difference. So the statement was you can call a function and a trigger. So yes, if you wanted to do something like that, you could drop it into a trigger where a trigger calls a function where you're passing through certain values.
Or maybe wrap your insert statement in a store procedure where you just pass them right in.
Yeah. And again, as with everything that we've been learning through the course here, these are all just tools. There's nothing that says thou shalt use the output clause everywhere, or you should use triggers everywhere. There's pros and cons to both, and hopefully getting through this, everyone can get a better idea of what those are in order to make better decisions when you're working in the code going forward.
Would you show the inserts again? Because I was thinking that the output was a statement at that point in time, not a clause, and I didn't know the context of it, like how long it lived, but now it's part of the original statement.
So we'll back up and let me close this window. And I'm going to try to just drop and recreate the whole thing like I did before. Start fresh. The question was, can I show the insert statements again? So like right here, this is the insert without the output. Plain old insert. We get one row's affected. That's it. We look at inventory, and that's where our chocolate ice cream. And you bring me back to the ice cream again, don't you, Bill? So I can see when we're done here, everyone's going to run out and buy ice cream. Then what we do is we just added the output inserted dot star inside of that same statement. So it's saying insert into inventory these columns and output everything that you got. And what that does is it performs the insert statement exactly as it performed before, but it gives you a result set that's being returned. So it's very similar to saying insert and then select star. If you could, there was a way to say, give me that ident inserted or something like that. Ident current to get the last thing inserted. And that's where you can get the result set there.
Yeah, this early on, before I realized, it looked like there was an insert statement and an output statement. And then I wondered how long the inserted thing lived till a go or another insert or something. But it's a
so
clause
really,
of the insert.
Yeah, it's a clause of the insert, so it's only available inside of that single statement. And that's a really good point. And notice at the end here we have a semicolon that terminates the statement. So it's only a single statement type thing. There's no. Now, however, you can use the into clause to insert it into a temp table or something else if you want to keep it around longer. Does that answer what you were looking for there?
Yeah.
Okay. All right.
Just keep it going for 5 minutes.
Yep. So we'll keep the Hangout open, or the video broadcast open for a minute to see if anybody has any other questions coming in. But in the meantime, visit emergencyreporting.com to find out more about emergency reporting. Or if you want more information on Aaron, you can look at aaronbuma.com or on Twitter, Aaron D. Buma, or to find me on the web, stevestedman.com, where you can download the slides from today's presentation, as well as the sample code, or you can find me on Twitter at SQLEMT. And that wraps it up for today. Oh, tune in next week. I forgot about this one. Actually, I didn't update the date, so it's going to be Thursday, 2/24 at 9 a.m. Pacific time. and the topics are going to be data recursion. I know we hit a little bit on recursion with common table expressions, but for data recursion, we're going to go into a lot more detail here with self-joins, range hierarchies, and then some really cool stuff to do with the recursive CTE on some better formatting. And then we're going to cover the merge statement. And on the merge statement, we'll take a look at the output clause as well, because we skipped that in today's presentation because we haven't covered the merge statement yet. And that'll be available free of charge from emergencyreporting.com next week. Any other questions?
Nope. I don't see any. But they're not to that point.